When everybody comes back, you can do that. Now, wait a minute. Did he go without the pass? He didn't even sign out. I'm telling you, he did not sign out.
Oh, leave it cracked.
Physical structure of decay, particles and energy. Okay? Alpha particles. They are made of 2 protons and 2 neutrons. So they have the same physical structure as a nucleus of a helium atom. The difference is an alpha particle comes from the nucleus of an atom, okay, and it doesn't have any electrons. All right? Beta, physical structure. It is essentially the same kind of particle as an electron. It's not an electron. It's the same kind of particle or elementary particle as an electron. It's very high speed, and it comes out of a neutron in the nucleus. Okay? So this just comes out of a, you got to sign in and out. You got to take the bathroom pass with you, and you didn't do that, so you got to back up and do it now. Violation. Shh. Danger, danger, Will Robinson.
Okay, so the E negative, the electron is like the same thing as the 2 positives. It's like the 2
Wait. See, now I can't hear you, and I'm sitting 2 people away from you. I want to start to get really upset here if we can't control the volume, okay? You need to know this stuff. Even if you think you know it, repetition doesn't hurt you a bit. It can only help you, okay? All right, try again.
Okay, so like where the 2 P plus and 2 is like the structure, and then the electrons like the structure.
Okay. I mean, I was telling you about some other things about it too, okay, and where it comes from. So this comes just out of the nucleus. The nucleus of a large atom that's going through decay gives away this particle. So it becomes, it has, the result of that is a particle, besides its alpha particle, is a whatever's left has a mass of 4 that's less and an atomic number of 2 that's less. Okay? And when we have beta decay, we take one of the neutrons in the nucleus and turn it into a proton. Okay? So we have 1 less neutron and 1 more proton in that nucleus. And then gamma is pure electromagnetic radiation. Okay? It's the most dangerous form of electromagnetic radiation. It's what made the Hulk. No, come on, it's a comic book character, but I mean, I just thought I might tie it in. Supposedly. We don't have any, it's not, so far as we know, that can't really happen. But it's a fun story, okay? No. You hit by gamma radiation, you get killed. Now listen, be quiet. I'm sorry I even said it. So you're making me regret having a little fun. Really? All right. So it's very high frequency, very tiny wavelengths, and very, very dangerous.
So what's the charge?
Well, if this particle, alpha particle, has 2 protons and 2 neutrons but no electrons, what kind of charge does it have? 2 positive. And if this particle is an electron, that's all it is, it has what kind of charge? A negative charge.
What about this gamma?
Gamma has no charge. Yeah, it's free. Sorry I said that. Don't start talking. Okay.
What kind of radiation causes radiation?
Mostly gamma.
What's radiation sickness?
Can we do that another day? Sure. Okay.
If you have radiation sickness, like major radiation sickness, is it possible to recover from it, or is there no?
Well, that depends on what you be my major.
Okay. Like you're on the brink.
Well, that's another question for another day. Okay. Marissa, you have a question about chemistry?
It's about radiation.
Does it have something to do with about something that has to do with, will be on the test on Monday?
No, we'll do it another day.
Okay, I'd appreciate that very much. I'd like to stay focused if we can, on point.
I promise for the next one, this is the last question I'm going to ask.
Okay, is it about this stuff?
Yeah, it is.
Okay.
Okay, so on here, you have like, what's the symbol for gamma particle and then what's the symbol for gamma radiation? What's the difference?
They're both the same essentially, except that when we're doing nuclear equations, we usually use this symbol here. Okay?
So that's what there's like.
Pretty much. You don't use a different symbol for one over the other. It just depends. It's contextual. Okay, as to which one you should use. Okay? Now I know Brian just knows all this stuff, but do all of you know this stuff and you don't need to pay attention? And do you really think that everybody around you needs to be distracted? Really? Come on, guys. Please, work with me here. All right? Yes?
What's the difference between a particle, a molecule, and an atom? Because
Okay, let me do this. Let me stop this first.